Focus and directrix of a parabola. So previously we have learned that all parabolas open up or down. You actually can also have quadratics that open left or right. So the way that we work with the ones that open left or right is we look at something called the focus and the directrix. So the focus is a fixed point inside of the parabola on the axis of symmetry. The directrix is a line outside the parabola perpendicular to the axis of symmetry. So what this means is here would be the example of the focus, here's the vertex, and here's the directrix. So the reason why these are important is the focus and the directrix are equidistant from the vertex. So the vertex lies halfway between the focus and the directrix. So any point on this parabola can be written because they are equidistant from the focus and the directrix. So this coordinate here is the same distance to the focus and the directrix. This coordinate here is the same distance from the focus and the directrix. The focus is always on the inside, and the directrix is always perpendicular to the axis of symmetry on the outside of the parabola. So let's look at the up and down parabolas using focus and vertex. So we've done the up and down parabolas using regular A values with a vertex and the zeros, but let's look at it using the focus and directrix. So this is the layout, this is the shell of the equation for a parabola open up and down with a focus and a directrix. So this p-value is all we change in this equation. So p is the distance from the focus to the vertex, or it can also be described as the distance from the directrix to the vertex. Because remember that the vertex is right directly in the center of the focus and the directrix. Vertex is right in the middle of these two. So whether I count from the focus to the vertex or the directrix to the vertex, the p-value will be the same no matter what. So I've got two axes here. So let's first talk about what will it look like if the parabola opens upward. Well, if the parabola opens upward, that means my focus is going to be somewhere along the axis of symmetry, which is right here. The axis of symmetry is this y-axis. So this little red dot is the focus. And the directrix will be somewhere outside, perpendicular to the axis of symmetry, which is a horizontal line in this case. Now, this only happens when your 1 over 4p, whatever number this is greater than 0. So if you have a positive a value, because that's basically what this is. This is essentially an a value. Positive a means you're opening upwards. Now, where you find the value of p is from the focus to the vertex, so that's going to be p, or you can count from the vertex to the directrix, that is also p. Now, what does it look like if it opens down? So if it opens upside down, you've got a parabola that looks like this. And again, the focus is this way now. The focus is always inside the parabola, and the directrix is on the outside. And this happens when your value of 1 over 4p is less than 0. So if you have a negative a, your parabola opens upside down. And the way you find the value of p is you count the distance from the directrix to the vertex, or count from the vertex to the focus. So let's look at a couple of examples. Let's look at the first one on the left. So let's do this one together. So write the equation for the parabola shown below. And so first thing I like to notice is that it's opening upwards. So that means I'm going to use y equals 1 over 4p x squared. Then all I need to do is find the value of p. Well, the value of p is the distance from the focus to the vertex or from the vertex to the directrix, and they should be the same. So if this is at a focus of 0, 2, that means from the vertex to the focus is 2 points or 2 units. If I look at the directrix, this is a y equals negative 2, and so the distance is 2 as well. So my p-value is equal to a 2. Now, it is a positive 2, and the reason why it's positive is because the parabola is actually opening upwards, which is what makes the p-value positive. If the parabola was opening down, it would be a negative p. So when we write our equation, we're going to have y equals 1 over 4 times our value of p, which is a 2, and then x squared. And I know that 1 over 4 times 2 makes 1 over 8x squared. So here would be my equation for this parabola. Pause the video, try the example on the right. And here's your solution to the second example. Now let's look at what happens if I don't give you the picture and I give you a description of what the quadratic function looks like. So write the equation for the parabola that has a focus at 0, 3 and a directrix at y equals -3. Then sketch the parabola. It's actually easier if you sketch first. So I'm gonna draw in what I'm given. So a focus is a coordinate at 0, 3. So 0, 3 is here, and I'm gonna label it with an F. And it tells me the directrix is at y equals -3. So when you have this y equals, that's telling you that this is a horizontal line. So y equals -3 is here, and I'm going to draw my horizontal directrix here. Now, I do need the vertex, and so what we're going to do to find the vertex is directly in the center of the focus and the directrix. So I'm going to count. 1, 2, 3, 4, 5, 6. The focus and the directrix are 6 units apart. So directly in half of that would be 3 units. And so that means the vertex has to be 3 units from either the focus or the directrix. So this is 3 units, and so is this. So my vertex for this example is right at 0, 0. Now the last thing we need in order to find the equation is I have to know if I'm opening up or down. Well, the focus is always supposed to be inside of your quadratic function. So if the focus is up here, that means I need to be around the focus. I need to be facing up. So since I'm facing up, I know that the equation will be a y equals 1 over 4px squared. So my job is to find out what the value of p is. So p is this distance from the focus to the vertex. And so p is going to be a positive 3. And it's positive because the parabola is opening upward. And so when I substitute in my positive value of 3p, so y equals 1 over 4 times 3x squared, my final equation becomes y equals 1 over 12x squared. Pause the video, see if you can try the example on the right. And here's your solution for that example. Now we've talked about the up and down parabolas. What about the left and right parabolas? And so the equation now is looking like this. So the difference between what we had previously and this equation is that this has x equals and the y is actually squared. So left or right has x equals, up or down is a y equals. And p is still the same definition. So p is still the distance between the focus and the vertex, or the vertex and the directrix. So what is this going to look like graphically? Well, if we have a parabola that opens up to the right, so I'm going to have the vertex at 0, 0 for now. And if the parabola opens up to the right, my focus has to be inside the parabola, and so my focus would be somewhere here. And the directrix lies outside. Now this time it's a vertical directrix, because the axis of symmetry and the directrix have to be perpendicular. So this is the axis of symmetry, and that means to make it perpendicular, I need a vertical line. Now the p-value doesn't change. The p-value is still from the vertex to the focus or from the vertex to the directrix. That's still your value of p. So a right opening parabola happens when 1 over 4p is greater than 0. So if it's positive, it opens to the right. And now for a left opening parabola, starting at 0, 0, it opens up left, so the focus is always inside, so this may be the focus. And again, the directrix is outside, perpendicular to the axis of symmetry, so this would be the directrix. And the p-value is still from the vertex to the directrix or from the focus to the vertex. Either one of those is the value of p. And a left opening parabola happens when 1 over 4p is less than 0. So let's do a couple of examples. So the first one on the left, write an equation for the parabola shown below. So the first thing I notice is that this is opening to the right. So since it's opening to the right, I have to have x equals 1 over 4p y squared. And now that I know that it opens to the right, I need the value of p. And p is the distance from either focus to vertex or vertex to directrix. And if you notice, I don't have my focus. All I have is the directrix, which is fine. I know that my p-value is the distance from here to here, and that's going to be a distance of 2. Now it's a positive 2 because you are opening to the right. Opening right is a positive p-value. Now that I have my information, let's write our equation. So 1 over 4 times a positive 2 squared. And 1 over 4 times 2 is 1 over 8y squared. So this is the equation for the parabola above. Pause the video, try the example on the right. And this should have been your solution. Now again, what happens if all you have is a description and not a picture? Well, create a picture yourself. So write the equation for the parabola that has a focus at -4, 0 and a directrix at x equals 4. So the focus is easy because it's a coordinate. All I got to do is plot the coordinate. The directrix is a line, and x equals are always vertical lines. So I'm going to find the x value of +4 and do a vertical line through that x value. Now again, we need to find the vertex. So count the distance from the focus to the directrix and divide it in half. So focus to directrix is 8, and if I divide that in half, I get 4. So 1, 2, 3, 4. The vertex is again at the origin. And also, I know it opens up to the left because it has to go around the focus, and so it has to open left. So since I now know that it opens left, I know that the layout is x equals 1 over 4p y squared. My job now is to find the value of p. And p is the distance from the focus to the vertex, or the vertex to the directrix. So the value of p is going to be a -4. And the reason it's negative is because it opens to the left. And now we have our value of p, we can substitute it into our equation. So 1 over 4 times the p-value of -4 y squared. So x is equal to a -1 over 16 y squared. This should be a comma on 1, 0. Pause the video and try the example on the right. And here's your solution for example